Hello, and welcome to this introduction to stoichiometry. In this video, we'll be covering the basics of Stoic and working through a few sample problems. So here's problem one. Suppose we have 2 moles of oxygen gas and we want to know how many moles of water we can produce. So the first thing we're going to want to do is balance the chemical equation. So we have 2 hydrogens over here and 2 hydrogens over here. So the hydrogens are balanced. 2 oxygens over here and only 1 over here. So we're going to want to multiply this by 2, but then now the hydrogens are unbalanced. So there's 4 over here and 2 over here. So if we multiply this by 2, we should be balanced. And the next thing we want to find is what we have. What we have is 2 moles of oxygen gas. So this is what we're starting with. So we have 2 moles of O2. We put a multiplication symbol beside it. Now the next thing we want to find is what we're looking for. So we're looking for how many moles of water we can produce. And to figure this out, we're going to have to convert moles of oxygen to moles of water. And we're going to use the mole-to-mole ratio. So how you use the mole-to-mole ratio is you find on your balanced chemical equation the compound you're looking for, so water here, and you have 2 of them. So you have 2 moles of water, and you want to put this over, since it's a ratio, your water, or your oxygen, sorry. You're going to want to put this over your oxygen. So it doesn't say, but there's actually 1 here. There's only 1 mole of O2. And you see how these units cancel. So moles of O2, moles of O2, and then you're left with your moles of water. And the only things left over would be your moles of H2O and your coefficients here, which will add up to the moles of H2O you can produce with 2 moles of water. So we don't need our calculator for this one. It's just 2 times 2 over 1, which is 4 moles of H2O. And that's our final answer. Now in our second problem, suppose we have 10 grams of aluminum and we want to know how many moles of hydrogen gas we can produce. The first thing we're going to want to do again is find the balanced chemical equation. So we have one aluminum over here and 1 aluminum over here. So they're balanced, 1 hydrogen and 2 hydrogens. So we get a 2 over here. And now we have 2 chlorines and 3 chlorines. So we're going to want to find the greatest common factor between 2 and 3, since we can't multiply 1 to get the other. So the greatest common factor is 6. So we're going to want 6 chlorines over here, 6, and we're going to want 6 chlorines over here. So 2 times 3, 2 times 3 is 6 chlorines. But now that messes up your other elements, so we're going to want to find how many hydrogens over here. So there's 6 hydrogens over here and only 2 over here. So I'm going to multiply that by 3. 6, our hydrogens are balanced. And the aluminums, so we have 2 aluminums and only 1 over here. I'll do this by 2. And now this is balanced. And that's about as complicated as balancing chemical equations will get. Now after we've done that, we want to figure out what we have to start with. 10 grams of aluminum. And what we want to convert that into. So we want to convert that into how many, we're going to convert that into moles of hydrogen gas. We want to know how many moles of hydrogen gas we can produce from 10 grams of aluminum. But we can't convert straight to the moles of hydrogen gas because we're in terms of grams here. So we're going to want to turn these 10 grams into the amount of moles of aluminum we have. And there's a process through this. You have to use the molar mass. It's represented MO. So the molar mass of aluminum. And to find that, we just go over in the periodic table. The molar mass of aluminum is 2.98. 26.98 is what I would say. And that's in terms of grams per mole. And you see why we could use this to use unit cancellation to get moles or grams, whatever we'd like. So we have 10 grams of aluminum, and now we want to figure that out in terms of moles of aluminum. So we put 1 mole on the top because it's 26.98 grams per 1 mole. So there's 1 mole for every, or 1 mole of aluminum for every 26.98 grams of aluminum. And so now we're in terms of moles of aluminum. Now we can do our mole to mole ratio. So we have 2 moles of aluminum for every 3 moles of hydrogen gas. But we want to figure it out in terms of hydrogen gas. So we put that on the top. So 3 moles of hydrogen over 2 moles of aluminum. And so all these cancel, grams and grams cancel, and then moles and moles cancel, and we're left with moles of hydrogen. And that's what we're trying to figure out here. So we're going to want to get our calculators out now because it's not just simple integers. So we're going to want to do 10 times 1 divided by 26.98 times 3 divided by 2. And you just go in steps of dead mass, and then that will get you to 0.56 moles hydrogen of H2. And that's your final answer. So now we're on problem 3 here. So suppose we have 5 grams of methane, and we want to know how many grams of carbon dioxide we can produce. So like the others, the first thing we're going to do is balance our chemical equation. So we start with 1 carbon and 1 carbon. So we're balanced with 4 hydrogens and 2 hydrogens. So we're going to want to multiply this by 2. So they're balanced. And then now we have 2 oxygens on this side and 4 oxygens on this side. So we're going to want to multiply these by 2. So now we have 4 oxygens on this side, 4 oxygens on this side. Now we're balanced. The next thing we want to do, figure what we have. We have 5 grams of methane, and you're going to want to write that down. 5 grams CH4 times, like we did in the last step, I put the big line, and the molar mass CH4. This one's a bit trickier than the last one. So if you look at CH4, has 1 carbon in it. And if you look, the molar mass for carbon is 12.01. And now you have 4 hydrogens. So for 4, because there's 4 of them. And the molar mass for hydrogen is 1.008, or just 1.01 rounded. And then this should equal, I'll do my head, 16.05, sorry, 0.05 grams per mole. Now that we have that, and we want CH4 in terms of moles, we can put 1 mole of CH4 over 16.05 grams of CH4. And then these will now cancel, and now we're left with moles of CH4. And now we want to figure out what we want to convert that into. We want to convert that into how many grams of CO2 we can produce, how many grams of CO2 we can produce. So before we only ended with the amount of moles, but now we're going to figure out how many moles of carbon dioxide we have, and then we're going to want to turn that back into grams. So it's going to be the reverse process we just did here. So first we're going to convert this to moles of carbon dioxide. So we have 1 carbon dioxide here per every 1 CH4 over here. Oops. For every 1 CH4 we have 1 carbon dioxide. So 1 mole of CO2 per 1 mole of CH4. And this won't have any effect because it's 1 over 1. Obviously you can see that. It'll be multiplied by 1. But in other cases, like the last question, you could have a mix of 2 and 1, or 1 and 2, vice versa. So now we have it in terms of CO2, and we're going to want to turn that into grams of CO2. So to do that, we want to figure out the molar mass of CO2, and that will equal, remember carbon is 12.01, and you want to add, sorry, I didn't put the add symbol up here for whatever reason, and now you want to add, there's 2 oxygens, and the molar mass of oxygen is 16.00. Rounded up, it's actually 15.99999. And this equal 12.01 plus 32, 44.01 grams per mole. And so now we want it in terms of grams of CO2 now. So since we want it in terms of grams, we're going to put them on top. So 44.01 grams of CO2 over 1 mole of CO2. And you see how this cancels and this cancels. Now we're left only in grams. I'll put the equal sign down here. So now we're going to do 5 times 1 divided by 16.05 times 1 divided by 1 times 44.01 divided by 1 equals 13.71 grams of CO2. And that is your final answer.